All right, ladies and gentlemen, welcome back. This is part three of our biomolecules. So this is organic chemistry, uh, pretty much just all the different molecules that we're going to be looking at in biology. All right, so let's get started here. So what is organic? Usually we have a little preconceived notion of what it is. It's this, excuse me, totally natural, no pesticides, no herbicides in our food. But is that what we're talking about in terms of biology and chemistry? Not as much. What we think about in terms of organic is whether or not it contains carbon and hydrogen, and we call those a hydrocarbon. Okay, we don't care if it has pesticides on it. All right, a couple other examples here. Methane and propane, they're both organic molecules. And now let's talk about just one extra little addition. We have hydrocarbons, but if we take a hydrocarbon and we add a little something extra, so here we have methane, and if we add an OH group, which is an alcohol, it's going to be methanol. So just by adding what we call a functional group to it, it changed the entire property of the molecule. So for example, ethane, which is a gas, if you add an OH group onto it, it's going to be turned into ethanol, which is a fuel or a solvent, or an alcoholic beverage. And this is just a little background into what we use ethanol for. So you can check that out if you would like. So monomers and polymers, this is the most important part so far of our video. What a monomer is just a simple organic molecule. When it's just by itself, we call it a monomer, but what it can do is it can bond or link together with other monomers to form a polymer. So let's look at a couple examples. Excuse me. These are the most important ones. These are the ones that we're going to have to know. So amino acid is the building block or the monomer, and it makes up protein. Glucose is the building block or the monomer, and it makes up starch or cellulose or glycogen. So you'll see all of those soon. We also have glycerol and fatty acid. What that makes up is a lipid. We also call it a triglyceride, or in other words, a fat. And then finally, we have nucleotides, which we use to make up our nucleic acid, like DNA and RNA. So stop that for a second and jot it all down. The last couple of things here, we have two types of reactions. We have a dehydration reaction, which we know if you're dehydrated, we lose water. Okay, we're also going to have a hydrolysis reaction where we're going to be gaining water. So let's look at it. So when an OH and an H are removed from monomers to create a polymer. So what we have here is we have a monomer, and the monomers are always going to end in H and OH. So if we come together with another monomer, so here's our monomer ending in H and OH, what happens when those two come together, the OH and the H come together and form water. So what happens is we end up having this monomer joined together with another monomer, and then we're also going to have that water that's left. Okay? And so this new thing that's come together is called a polymer. Okay, so you can jot that down, and we'll move on to the next one. Little visual there, dehydration, losing water, drop, drop. All right, so the hydrolysis reaction is the complete opposite. This is using water, or taking in water. So this is where we have a polymer that breaks down into monomers. Okay, and it uses water. So water's kind of got two functions here. The first one is let's get that monomer back up, or that polymer back up. Okay, so here's our polymer, that's because we have two monomers joined together. What water is going to do is it's going to come and it's going to break that bond. And when it breaks that bond, the OH and the H of water are going to join those existing monomers. So what's going to happen, let's get back to some redness. So we're going to have our OH, our monomer. We're going to have our monomer and our H. And now those OHs and Hs from the water are going to join. And now we have our original monomers back. So now those polymers are broken down. So water is used to break it apart, and it also joins the monomers. Okay? So that's it for our, excuse me, that's it for our dehydration hydrolysis reaction. They happen in every single type of reaction that we're doing this year with organic chemistry. Okay, so we're going to see this a lot in class tomorrow, so hopefully that helps. And if you have any questions, be sure to jot them down.